So the objective of this particular problem is to determine the empirical formula. So you're given that there's an organic compound. It contains carbon, hydrogen, and chlorine. So you see that right here. You are asked again to determine the empirical formula. There are two experiments, and you're going to use those two experiments to get the elemental information. So experiment 1, it's important to note that there's 1.5 grams of sample. This is completely combusted to produce 3.52 grams of carbon dioxide. A second experiment is done, a different sample size is used. It's 1 gram of sample, and this sample, through some process, is converted to silver chloride, and you're given the amount, it's 1.27 grams. Now what's important to realize is that from experiment 1, you can determine the amount of carbon. Specifically, you can determine the mass percent of carbon in this compound. From experiment 2, you can determine the amount of chlorine. Again, specifically, the mass percent of chlorine in this compound. The mass percent of the carbon, hydrogen, and chlorine in any sample size of this compound will be the same. That's also important to recognize. So experiment 1, first thing we're going to do is we're going to convert, we're going to first recognize that the moles of carbon that are in the original sample are completely converted to carbon dioxide in this combustion process. So we can determine the moles of carbon because we're given the amount of CO2 produced. That times the inverse of molar mass of CO2, 1 mole CO2 per 44.01 grams of CO2, gives us moles of CO2, and again there's a 1-to-1 relationship between the amount of carbon in the original sample and the moles of CO2 produced. So again, keeping track of units, grams cancel, moles of CO2 cancel, leaving us with moles of carbon. We get the moles of carbon. We then can convert that to grams by multiplying the moles of carbon by its molar mass, which is 12.01 grams of carbon per mole of carbon. This gives us our grams. Now mass percent is just that gram quantity divided by the sample size, and in experiment 1, that sample size was 1.50 grams. So in this compound, 64% by mass is carbon. So now for experiment 2, we can gather information about the amount of chlorine. It's important to recognize that for every mole of chlorine in the original sample, that is converted to silver chloride. So there's a 1-to-1 molar relationship between the chlorine in the original sample and the moles of silver chloride produced. So to get the moles of chlorine, we can take the amount of silver chloride that forms times the inverse of silver chloride's molar mass, then multiply it again by that molar ratio. It's 1-to-1 of chlorine to silver chloride. Looking at our units, grams will cancel, moles of silver chloride cancel, leaving us with moles of chlorine. As before with the carbon from experiment 1, we can figure out the grams of chlorine by simply multiplying the moles of chlorine by the molar mass of chlorine. That gives us our gram quantity of 0.3140 grams. Mass percent of chlorine in this particular sample, therefore, is just that 0.3140 grams of chlorine divided by the original sample. For this experiment, there was 1 gram of sample. So this gives us 31.4% of chlorine in our compound. Again, it doesn't matter if it was 5 grams, 10 grams, the sample size is not going to influence that mass percent. This is important. So therefore, at this point we have information about carbon and we have information about chlorine. And so we know that to get the mass percent of hydrogen in our sample, it's just simply 100% minus the sum of those 2%. This is for the mass percent of carbon, and this is the mass percent of chlorine, which we determined previously. So the mass percent of hydrogen in our sample is 4.55%. So we want to figure out empirical formula. Percentages, it's easy to assume that we have a 100-gram sample, and then we convert grams to moles. So if we have a 100-gram sample and 64% of it by mass is carbon, we have 64 grams of carbon. If I have 31.4% by mass chlorine in a 100-gram sample, I have 31.4 grams of chlorine. If I have 4.55% hydrogen in our sample, and this is a 100-gram sample, I have 4.55 grams of hydrogen. Multiplying each of these by the inverse of the molar mass for carbon, for chlorine, and for hydrogen, we get the respective mole quantities of carbon, chlorine, and hydrogen in this 100-gram sample. We can then divide each of these mole quantities, we're using those as our subscripts, divided by the smallest mole quantity, which is the 0.886 for the chlorine. And this is going to give us our empirical formula for this organic compound.